Welcome to an edited down live stream that occurred on June 9th of 2021, where I rode the struggle bus once again to design a part that I had no idea actually already existed and could be had for less than $10 on Amazon. It is a base for the wireless module for the DJI Osmo Pocket. Yeah, sometimes you win, sometimes you lose, but it's going to help us spearhead a new series coming out that's going to be all about making it yourself or just buying it off the shelf, because sometimes it's just not worth the effort. And this would be one of those times where I would say go buy the friggin' part, because it's so darn cheap. Anyways, I hope you guys enjoyed this one. And remember, of course, if you get frustrated with CAD, you're not alone. That's why we do these live streams, so you know that you're not alone. And you can always follow along. And remember, they happen every Wednesday at 5 p.m. unless otherwise scheduled. I'll see you guys in the comments. Have a good one. How's everybody doing? Hope you guys are having a lovely Wednesday afternoon. I don't know. Whenever the heck it's this afternoon, we are going to be making parts for this camera. I will explain about this in just 1 second. But yes, the ever effervescent Victoria has graced us with her presence today, and she's currently taking a bath. Let's talk about the camera for a minute, and then we'll get into what we're going to make for it. This is the DJI Osmo Pocket, and normally that's all that it is, okay? A DJI Osmo Pocket is a DJI Mavic camera that's handheld. So when you turn it on, it is actually a, here, I'll flip it around. Actually, just flip it around this way so you guys can see it. It is a gimbal stabilized camera. There is a pretty decent community out there for these because they're incredibly cheap. I paid no more than $175 for these things used. If you want them brand new, they're like $200. The brand new one is $350. An issue that I have with the Osmo Pocket is you would think for a camera of this size that it would have a 1/4-20 mount, and it friggin' doesn't. I'm going to bring up Big Grant so you guys can see. There is no way to mount this thing to a damn tripod. I want to hold it from the bottom because the fact that it can rotate almost 360 degrees is incredibly valuable. So you can set it up in the middle of a room that you're working on and have it pan across multiple times during a hyperlapse or a time lapse. So I'm like, yeah, I can do this better. It's just got USB-C in it. It has a USB-C out, which is something that we need to take into account because this does allow pass-through charging. Let's get to designing. All right, we're in Fusion. As always, we're gonna start. This piece is gonna be better from the top because I'm gonna extrude straight up. And what we're gonna do is we're going to create a piece that this can slide into, okay? So it's going to have to grab it down at the bottom and then reasonably follow this contour. So as it goes in, it can really only go in one way. And then we will be able to screw it into a 1/4-20 thread mount. 1/4-20, that's 1/4 inch, 20 threads per inch. 1/4-20, there you go. We're gonna try out two different methods for this. I'm gonna actually create threads in this part. I don't know if that's how we're gonna end up doing it because of course plastic threads are nowhere near as strong as metal threads. So we may end up going to a heat set threaded insert, but that'll be a channel video if and when that does happen. So let's start with it. Let's grab our sketch. Let's scroll to the top. Let's do that. Let's get our diameter. We're going to measure it. So we talked about draft in that last video. You guys can see the draft on that. You see the angle? That's draft. And so when you want to measure something with a draft on it, you got to get all the way to that outer edge. 39.5. We're going to call it 39.5. I'm going to up it to 39.75 to give us just a little bit of room. And I'm going to show you what I'm going to do. I'm going to make the walls relatively thin and add a little detent. But so let's go ahead and get our design on there. 39.75. That is the base. So this is the base of our unit. We want to have it be a little bit bigger than that. So to do that, we hit O for offset. So I'm going to go 2.5 millimeters on that. Gives us a good base there. And so I want to add some lines. But to do that, we need to first do the lines that we always want, which is L and X, are construction lines, to come up. Get it way out of the way, hit escape, hit the L key again. Go out to there, randomly hit X, hit escape, and that way you are no longer in your construction. We want to create something so it slides and clips in. There are a few different ways we can do it. But the way I'm thinking, I want to do a line from there. I don't know, man, maybe there. And we're going to end up mirroring it, so let's look at doing some lines here. So I want this to be, let's grab a dimension. We're going to grab that to the center point there, because we want to know, are you not going to give me an angle? Seriously? All right, fine. We'll do it from here to this top. Okay, so at 90 degrees, that would be a perfect half moon, but we want to go a little bit further. That way it'll lock in when we put it inside. We don't want to go too much. Okay, so if we go to 90, you don't let me change that? Oh, no, it won't, because it thinks that it is over constrained, so we got to redo that constraint. That is 90. I want to make it 70. And that's going to really force you to push it in. That might actually be a little bit too much. Let's do 75. That should be good. That should be a C that really grabs it in. On this side here, we're going to do a couple of lines. So let me grab my line tool. I'm going to come straight down. That should be okay. We're going to go with a mirror here and here. Mirror line is that. We're going to click OK. And the reason we're doing this is I want to create a small, a little nib, so that when you slide everything in, it kind of locks in place on the backside as well. So you have to bend it out and then you can slide it. All right, let's first get ourselves a good looking base here, because as Megan Trainor says, we are all about that base. I'm just do everything with a factor of 2.5. Actually, I don't know if we want to do that. So we have to design it for the fact that we're going to have a heat set threaded insert in there. These are those inserts. Now, those inserts are 6 millimeters in diameter and 8 millimeters in length. Okay, 6 millimeters tall, 8 millimeters OD. Now, here's the deal. Threaded inserts can be a real pain in the ass, but that does mean that this needs to be at least 6 millimeters deep and likely should be probably 8.5. So, oops, Grant went the wrong way. Minus 8.5. Gonna bring that sketch back because that sketch matters, but we should... I gotta go back into the sketch and make a few other changes. So, let's do a circle. We're gonna do this to 0.25 inches. And we're going to do another circle to just under 8 millimeters. So like 7.5 millimeters. That one's going to be fun. All right, so we're going to finish the sketch. We are going to also do, not a press pull. We're going to do E for extrude. Where'd you go? Right, you're over here, you dingus. This is the hole that we're going to be using, but I want it to be an offset plane. We're going to offset it by 8.5 millimeters. And it's going to be negative 8.5. And we're going to have it go in probably positive 6.25. Give you a little bit of extra just in case. Okay. And we're going to immediately thread this so that I don't forget. But here's the problem with Fusion and a lot of programs. Chamfer your hole first. When you're dealing with threads, you want your threads to be chamfered. Chamfering threads matters a lot. So we're going to chamfer this like a millimeter. Something relatively large. And that should work. Now, when we do our threaded insert, we will if we end up having to do the threaded insert, we're probably just going to have to drill this out completely. Kind of is what it is, unfortunately. You got to work with what you got. So we're going to grab that. It is a... yeah, I can just cheat and pull in a 1/4-20 bolt, which I think is what I'm going to end up doing. All right, we're going to cheat. Maybe this is 1/4-20. I don't know. If it's not 1/4-20, it's going to be. That shrunk way down. Interesting. All right, let me scroll back. I'm gonna redo these threads because it looks like it's not taking with the chamfer, and that's my concern here. Yeah, see, it doesn't look right. It should be an Acme screw thread. So I don't know why I'm only getting... Oh, hey, found it! Yes! Ah! Golly, it's under ANSI, Unified Screw Threads. I'm going to push this out here. That did not get mad at me? No kidding. I'm going to move that there. That's not going to work. So, yeah, not amazing, but that should be quarter 20. Let me look at opening up this hole a little bit from 6.35. Let's go to 7 and see what it looks like now. Because when Fusion does threads, it should just accommodate stuff. Radius 2.558. That's only 4 millimeters. I don't know. It's probably going to work. And if it doesn't, it doesn't. But what I have learned, especially, is make sure you offset all of your faces when you're doing this kind of thing, because you are going to mess up and your printer is not going to be perfect. So I'm going to offset it by probably -0.1. And if I'm right, that should expand the threads a little bit. Yes. Okay. And that's good. That gives me a little bit of wiggle room. Actually, yeah, I'm going to give myself more wiggle room than I need, because it's going to end up screwing down flat to this plate, so I just don't care. All right, so we got our bottom threaded hole, and yes, we could do heat-setted threaded inserts, but thankfully, because I'm not a complete and utter moron, I was able to find this. That's a joke, because I am a complete and utter moron, and I missed it for a little bit there. Either way, I'm pretty happy with that. That's going to get the job done for us. Now we're going to go ahead and do our second extrude, E for extrude. We're going to bring this up. Now, if we look at the base plate for the Osmo Pocket, it is 22.6 high, and then the Osmo fits directly into it. So I'm going to do an offset plane from here at 22.75 from the top, which puts me right where I should be. I'm going to create a new sketch here. I feel like I should try to model their piece first and then look at building a mount for it. So I think that's maybe what I'm going to try to do first. Grab me all of my reference measurements, all of that stuff. I think that's all I'm going to need further up. Yeah, it should be all that I need further up. Bring the body back in, but honestly, that body's just going to cause us problems. So we're going to take some basic measurements and actually build this piece the way that they would have built it. Okay, so we're about 8.3 millimeters up from the bottom here. Then it looks like it's lofting. So that's what I'm going to do. I'm going to loft, not revolve. I'm going to loft between this profile and, dang, it's not... Okay, it's going to let me do it this way. Oh, boy. Oh, it's so mad. It's all self-intersecting. Okay, there we go. Is that really? Honestly, that's not that bad. Yeah, could be better. So I probably want... It has a very, very light fillet to it. I mean, even that might be enough. I'm going to say it's at least 1 millimeter. That's got a good fillet on there. That kind of gives us the idea of what it looks like. I'm going to turn back on Sketch 2. I'm going to go back into Sketch 2 as well, because I can actually measure the thickness of this. The Osmo Pocket is 28.66 by, at its widest, 22.83. All right, let me make another center rectangle on that, and let's see where that brings us. Nope, didn't click the center. So rectangle, center rectangle. Let me grab from the center there. Our width is, it's a consistent width on this thing, so just measure it with your calipers. 28.6 will go to I don't know. Nah, 28.6 is fine. 28.65 by, and so if we look at its profile, it does have a bow, so we want to find it where it's reasonably at its thickest, measured there, and that is 22.85. This should give us a reasonable idea of how they drafted everything in and how they built it. So, that does not help me one bit. I know for a fact that these are gone in it, and they're just turned into big fillets, so let's do something. When we did this loft, I'm going to make it a new body, because that's going to be important. I can turn off the loft. I need to create a sketch there. Or actually, no, I don't. I don't need to create the sketch. We can come to here. We have the loft on, and we are going to extrude. Sides aren't flat. Okay, we're going to extrude this and this. We're going to do an offset. Again, I believe that's 8.5 is what it was. And we're going to extrude up like 200 just to go through everything. So we'll do an offset of 8.3 and a distance of, I'm just going to do 50 so it's not that crazy. I think that should cover it. Now, I'm going to be on the safe side. I'm also going to add some of these outside ones in so it cleans up that outside edge. Nope. Yeah. So that way it cleans up that outside edge for us. Because there was a little bit of overhang. So we have that. Boy, that's some weird intersections. But that is honestly exactly how it looks. And they just filleted the crap out of this. So they have a fillet here and a fillet here that appears to be a reasonably smooth fillet. So, right, we now need to combine these two. So we can do modify, combine this, and sure, we're going to join them. Now we can do our fillets. And the reason I knew they weren't joined is the arrows was going in the wrong way. I'm like, oh, that arrow's not going in the right direction. So I knew to go ahead and fillet together. Ooh, you don't like that. And that is because of that fillet. So I'm going to come in here. This fillet is making everything else mad. So I'm going to suppress it right now. I've got a better idea. Let me roll back. I'm going to roll back to here because I need to do a new sketch. I need to do it here because I want it to loft only a part of the circle. And I think that's my issue right now is I'm lofting too much. So I'm going to turn off this body so it's out of my way. I'm going to turn off sketch 2 so it's out of my way. So I want to project this, that, this, and that. I think that's all I need to project. We're going to turn the body back on. Now we do the loft. I'm going to redo this first profile, and I'm going to say that I want it to loft here, here, and here into that. And I think, theoretically, that's going to get me what I'm looking for. Yeah, I think that's going to do it. We're going to join it this time because I don't think the rest of that stuff actually matters at this point. I'm going to add a fillet here and here to give me the fillet style that they use. This is why DJI products are so damn expensive. It's because they put so much friggin' effort into these stupid little things. Okay, and they use... Okay, I see what they're doing. 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 Oh, man. Okay, now they're coming in and they're doing these fillets. Okay, this is how they did it. This is how they did it. Okay. All right, we're going to do like I think a 2mm. No. That fillet is done before this. All right. I'm going to fillet this. Then we're going to do that that other fillet. 2? 2 might not be enough. Let's go to 1. I'll be damned. Other than the fact that this whole thing is drafted and angled, I think that's right. I think I know how to fix this. This draft, man, this part is tough to design. Yeah, see, it comes up. I think I know how to get rid of the, to deal with this draft. I think it's another loft, and it's going to require me to have both of those open. So let's create a loft and see what happens. We're going to come from this bottom side here. Okay. Probably could have just unclicked that. Alright. That's profile 1. Profile 2 is going to be this exterior. If I'm right, I want it to intersect. I didn't expect that it was going to be non-uniformly drafted, but it clearly is, because this is basically dead flat and this is not. Now, I could just ignore it, which part of me says to just freaking ignore it. Your part is still going to hold it in, and we can do what they did and hold it in on these sides, which is what I'm going to do. This person, whoever designed this, like whoever designed that Thingiverse thing, made the right decision. Holding it on this side here, on all of this, is like way easier. Because all you have to do is just get it, it's a slide plate, right? It just needs to slide in. Alright. Oh, I feel like an idiot for not thinking of this. We're gonna do a slide plate mount. This body, gone. Like, literally keeping it's going to bother me, so I'm gonna kill it. Okay, we're gonna turn off that sketch. Let's see. We want to do... See, this is what CAD's all about, right? It's about being able to look at it and say, what is really the best way to do it? My way is I was going to captively hold it and then have my USB-C port really easy to access. This time, I'm going to do similar to what these guys did. All right, so let's go ahead and remake the base. So the base... No, what? Grant, don't get rid of that. That base was still good. Getting rid of it would get rid of all of that threading that you did. So we're going to take body 2 and we're actually going to move it. And all we're going to do is we're going to rotate it. We would like to try to move it from a better location. There. All right, I'm going to rotate this thing 90 degrees because we're going to create something that kind of slides in and grabs. All right, so now we can look at creating something. Where's this extrude? This extrude's right here. Or we only got to come up like... Probably 12 is all that we need to come up. Yeah, 12 is good. Alright, so we're going to create a sketch. We're going to create it... Actually, I think we already have a sketch there. Yeah, sketch 4 is already there. Alright. So we can turn off body 2. Keep sketch 4 on, except that's where everything is. Invariably, we know that that space is clean. So we can come in, get rid of body 2. We can hit the extrude key. We can literally click up to there. That should be fine. I'm going to fix that. Don't worry. Yeah. That, honestly, it's actually going to hold it in just fine. Wow. All right. Hey, whatever. Now we're going to come to here. We're going to bring this up like... no, more than that. Probably just 1 millimeter, and we are going to fill it the ever-loving hell out of this thing so that it is just like a little bump. Just a little bump. Which reminds me of a buddy of mine whose name is, well, he goes by Bump. His real name's not Bump. His name is Josh. Oh, you're not gonna let me do that, are you? Alright, how much can we get out of this before it starts to get mad at me? Alright. So there, once it slides in, that's going to lock it in place. We've got the arms and wings there that are going to hold it. We're going to come back to sketch 1 because I can see something that we can actually fix, which is dealing with this. Should be extended all the way out. We're going to mirror that over the mirror line. Okay, and when we did this, that extrude, we'll do another extrude here and here. Get this the hell out of my shop. All right, now we're gonna fillet the crap out of it, and honestly, this should be all that we need to do it. I'm gonna do some more fillets here, just because it's gonna bother me if I don't. Let's do a 2mm fillet. That's fine. Theoretically, that should work. He says with no confidence whatsoever, that should work. Oh, man. This should allow us to kind of push it in and let it slide, drop down. I can't fillet any of that. I can fillet this, but I don't think it's going to matter. I'm going to fillet this entire top edge. That might be a little bit much. I'll just fillet all of these. I want it to feel good. I want it to feel good, man. So let's take a look. What else can I do? I'm gonna chamfer this bottom edge a little bit. Yeah, I gotta have my USB-C port. Totally forgot to do that. Which, I'm gonna put the Osmo in here, and let's see. So the USB-C port's on the back, so if I want the Osmo, it'll slide in. I'd rather it slide in like that than like that. Yep, that just feels better to me, so I'm going to edit this side and enable that USB-C port. The USB-C port is right in the middle, so we are going to create a sketch here, and honestly, that sketch should get moved all the way to here, where the part hasn't been filleted yet, because the fillets just add a bunch of complication that if you don't have to deal with it, you don't want to deal with it. All right, I'm going to measure. You don't just have to measure the USB-C port. You really have to take a measurement of cat. I love you, but I am busy. We got to add a USB-C port. The USB-C port on these bases is not in the middle as you would expect. I'm going to try to get that on the camera there. It is... That's that, that 8.3 tall, but it is how far from the top edge? It is 1.34 millimeters from the top, so it'll be from there. So I want to make sure that I can project this line. I can project... Actually, I'll project that whole thing. Project all of that. All right, so it is 1.34 millimeters down. So I'm going to create a rectangle because USB-C is a pretty big connector. I've got a USB-C cable next to me here that I'm going to measure, and I'm just going to measure this, and I'm going to make the hole big enough to fit this and more. So this is 6.5 by 12.5. So let's go ahead and dimension this out to 6.5 by 12.5 inches. So this should be 12. And this should be 6.5. And we need this to be about probably 1.25 inches from the top there. And we now need to take this and move it over because it is based dead center, just like that. So let's make sure that we draw our construction line from that origin point up. Let's get rid of the construction. We want to grab a, not text, Grant, we want to grab a point. We're going to find our midpoint, which is oddly really close. We're going to make it coincident. And there we go. That should be enough for the USB port. However, I'm going to make it just a little bit bigger. We're going to go up to 7. Right. It needed to be that distance away. And I'm going to make this 1.1. I want to have a little bit of space on the bottom there. And 12.5, I'm going to go out to probably 13. That should give me enough space. We're going to finish that sketch. Now we're going to hit extrude. We're going to extrude this all the way through, which was not... did exactly what I did not want it to do. I've got a little wall there, which should be enough. Honestly, I can probably get away with like 6.75. I just need it to catch on the bottom, right? If it catches on the bottom, we should be okay. The top up here just keeps it from falling out. But really, a lot of that force is held by this bottom piece. So let's finish that sketch. It's going to give us a little bit more. This is okay. Of course, we were going to need support in this thing anyways, so I guess I'm not too concerned. That should cover it. This is a little bit of a weak spot. and I'm a little concerned that it might not hold it. So I'm thinking that I want to delete that. No, I don't want to do that. Looks better with it on. All right, we can do that. And theoretically, I could do this on both sides. That way it can lock in kind of either way. But I'm not going to do that. We're going to do it this way. I'm going to save it. We're going to try it out. Yeah. But yeah, there you go. There's the part. I am not... let's back up and talk about it. I'm not pleased. And I'm not pleased because I couldn't do what I was expecting that I could do, right? I had my expectations for myself set too high. And I think that's one of the best lessons from this is know what you're capable of doing and know what you're capable of designing. Because you may not be capable of designing the things that you want. And that's where companies like 3D Musketeers come in handy. Because I am not normally one of the designers that makes parts. Those are our staff. I guess for me, this one was, I came into it thinking that I could do something that I couldn't. That's okay. I found a good way around it, and that is because of you guys, the subscribers specifically. I dig it. I think this ended up going okay. I was really risking just saying F it and be done with this, but hey, I'm glad I stuck it out. I'm glad you guys stuck it out with me as well. And if you want one of your ideas made live, can't guarantee it's gonna go perfect the first time, but damn it, I'm gonna try. Make sure you email us your ideas or comment them on these videos. That's what they're here for. It's here so we can all hang out, have fun, and make cool stuff. Anyways, hope you guys enjoyed this one. Stay safe out there. Don't forget to call your loved ones, and as always, keep making awesome.